All right, so in vertex form, we have what letters we learned yesterday. On the outside, we would have A. Now, I want to tell you, that's not really the real A. That's not the real A. Okay? It's an imposter. It's an imposter because the real A is only really in standard form. You have to multiply everything out. You have to multiply everything out to see the A value. All right, so if we look at this, remember the syntax of this is an x minus. This minus reminds you, take the opposite of what you see to build your vertex. So our vertex can be taken directly out of that equation. It's going to be the opposite of what we see. So what's the opposite of negative h? Positive h. So it's called the h value. And on the outside stays the same, positive k. So h comma k is the vertex. Well, if we know the vertex, we also know the symmetry. The axis of symmetry goes through x equals what? H. That's right. The x value of the vertex in this case is whatever h is. All right, let's do the example down below. So looking at example 1, vertex form is given to us. There's nothing else given to us other than the equation. Now we're seeing two shifts happening. Remember, the inside is a horizontal shift. The outside is a vertical shift. So this negative 4 inside tells us to do what? Shift in what direction? The opposite of what we think, right? So we're going to go to the right 4 units. And we also have a number, the k value is a positive 4. So also up 4. So that's our shift. 2 shifts. All right, now we have those values, those descriptions. We could use that to also fill out what h and k are. If you have to go, oh, I said shift 4. I didn't say which direction. No one stopped me. What's it supposed to say there? Right. It's supposed to say right. We said it, but we didn't write it. My fault. Right 4, up 4. So that tells us right there, h is positive 4. And k is also positive 4. H comes right out of the middle here, opposite, and the same on the outside. What's the a value out here? Negative 1. There's a negative there, so don't forget, that's like negative 1 in disguise. If you were to multiply everything out, you would end up with negative 1 for your a. Now we have what information? What does that tell us? That a of negative 1. What's it tell us, Morgan?
It tells us, so if a is negative 1,
Yep.
then everything would be negative, or like it would be times negative.
Yeah, you're right. You're going to take the step pattern and multiply it by negative 1. So instead of going 1, 3, 5, we're going to go down 1, down 3, and then down 5. So it turns that thing upside down.
Sad face.
It's a sad face, you're right. Negative a's are always sad. All right, so let's plot the vertex. The vertex is where? HK. We can build the vertex right from those values. The vertex is 4, 4. That makes sense because right 4 and up 4. If I go to the original x squared vertex, 0, 0. Right 4, up 4 is my new direction to the new vertex of 4, 4. Make sure that's the right one though.
When you do h and k, you have to distribute the negative that's outside the parentheses.
No, you never do anything with that negative there. H will not be changed by that negative. It's always the opposite here and same on the outside, regardless what A is. Okay, good question. All right, so let's use the step pattern to build our parabola. So we know it's down 1. So down 1 over 1 puts me on that coordinate there. And then reflect it over. What am I reflecting over? The AOS. What's our AOS here? It's 4. X equals 4 is our AOS. So we could help ourselves out to see our symmetry with drawing that vertical line right through x value of 4, right through the vertex. Now we could definitely see the symmetry happening with these coordinates. All right, down 1 and then down how much? Down 3. If I go down 3, where do I land? On the x-axis. So now I'm going to see what? What key feature are these? These are my roots. Okay, these are my roots. Okay, so the roots. And then from the roots, I'm going to go down how much further? 5. Down 5. 1, 2, 3, 4, 5 over 1. If I want to go down again, what's my next step? After 5 would be 7. 7. If I go down 7 over 1, it would land me on the y-intercept. That's right, on the y-intercept. Now, we don't have enough room to do that, but maybe another form might show us that. What form will show us the y-intercepts? Standard form. Standard form. Well, how do I get standard form if I'm only given the vertex form? If I'm only given the vertex form, how do I get to standard form? Simplify. That's right. Simplify. Multiply it all out to standard form. Go ahead and do that. And now as you are multiplying that out, you maybe think about, is there another way we could get to standard form based on what we have? If you're not sure, well, take what you have, multiply it out to get that standard form. It will be a trinomial. It will end up with a negative x squared in the beginning. All right, after you expand that power and you multiply through a box or distribution, and then you distribute the negative, and then you add 4, you end up with negative x squared plus 8x minus 12. And that's our standard form right there. What does that show us right now? Our y-intercept. Well, we couldn't see it on our graph, but now we have a way to find it. We can see it in our standard form. So here is our y-intercept. The y-intercept is 0, negative 12. That makes sense. If you go down 7 from here and over 1, you would land on negative 12. Yeah. All right, now could have been a faster way. If you're not very comfortable with these square quantities and you make mistakes a lot, you could have gone through factored form. Because how could you build factored form? You're given the roots after you graphed it. So after you graph it, you can build these opposite binomials in factored form. So remember, the syntax of that equation is always a and then x minus times x minus. So what goes in there are those root values. My roots are positive 2 and what's the other one? Positive 6. So x minus 2 and x minus 6. What's the a value that we saw in the step? Negative 1. So I can go ahead and erase that and put the a value of negative 1 on the outside, and there is my factored form. Now if I multiply this out, would I get the same thing I have up here? Yes, I would. Maybe you're like, nah, Mr. Van Meter, negative 2 times negative 6 is positive 12. But don't forget, there's the negative over here. All right, so our roots build the x-intercepts. Very good. The root value goes first, 2, 0, and then the other one is 6, 0. All right, now, let's do the last activity in your current groups. I want you guys to work together on example 2. Okay, example 2. You could go in any order you want on example 2, but work together to get all of that filled out. All right, so on this graph here, we notice that we have a huge shift to the, not a huge to the right, but a big drop down. Look at this vertex, that 2, negative 25, 2, negative 25. So we can start with our description of that shift to the right, 2, and down 25. All right, so let's now identify what the step is from the vertex. Since we're given the vertex here, it looks like it's going up 1 over 1. So it looks like it's going up 1 over 1, up 3 over 1. So that's holding true to our basic one. So A is what? It's 1. That first step is always the A value. That first step here, up, is that A value over 1. So 1, 3, 5, and that's the a value, the first thing. Now, we have the vertex given to us down here. So we can fill in h and k. H and k will always be the same in a coordinate. So what we see there is positive 2 for h and negative 25 for the k value. Now, what can we build? Well, we can't build standard form. Even though we can see the y-intercept is negative 21, but we don't know what the b value would be. Ax squared, so x squared plus bx. You can solve for it, like we did last week. Or you can use another form. Well, above we used factored form to go backwards. Can we do factored form here? No, because we are not given what? The x-intercepts, the roots. We can't see those root values. So we are stuck having to use vertex form. That's not too bad though. So set it up empty. Y equals our a value times x minus our h squared plus k. Fill in the numbers. A is 1, h is 2, and k is not plus 25, minus 25. Now we could do what? Standard form by undistributing or unfactoring all this stuff. Multiply it all out. So what's really cool, when you multiply it out, you can verify you have the right equation by looking at what key feature? The y-intercept. We should have something minus 21. Let's see if it works. So x minus 2 squared is x minus 2 times x minus 2, which is x squared, minus 4x plus 4. But don't forget, we have to minus 25 now. Okay. Again, these three terms came from multiplying this out up here. 4 minus 25, negative 21. So minus 4x, minus 21, and now we can verify we did it right. We have the same c value as our graph does, that negative 21. Last thing to do is factor. Why are we going to factor? Well, we want factored form to find what? The x-intercepts, the roots. So now we're going to factor this trinomial. That's a basic x squared. So what multiplies to negative 21 and adds to negative 4? 7 and 3. But which one's negative? Negative 7. X minus 7 times x plus 3. That does factor correctly because that would add up to negative 4 in the middle. Now the opposites will build our x-intercepts. What's the opposite of 7? Negative 7. Positive 7. Remember, it's also what makes these equal 0. That's another way to think about it. So positive 7 makes that go to 0. So one x-intercept is 7, 0. And the other one is negative 3, 0. May the math be with you.